Oh, hey. Hi. Thanks for watching these videos. Please remember to click subscribe, like, share them with your colleagues, and then click show more below each video. Lots of lesson plans and ideas, inquiry questions, perfect for your classroom. Thanks for watching.
I'd like to say a few more things about nuclear fusion and perhaps the life of the sun, because one of the common questions you'll hear is, will the sun blow up? Will it explode in some perhaps supernova? Well, the answer is actually no. So let me try to explain that to you. What I tried to do is find simple things that can explain complex actions. I have here a couple of golf balls, and I've placed on them positive signs to indicate that this is their charge. Let's pretend that these are hydrogen atoms. The neat thing about astronomy is you can factor in all the different sciences, such as, in this case, chemistry. Understanding atomic structure is an important thing to do. Hydrogen is the simplest of all the atoms on the periodic table. Simply a proton and one electron whirring around. If you said proton, I could say hydrogen. If you said hydrogen, I could say a proton. Really one and the same. And because they have the same charge, as they come together, they tend to want to bounce apart. They don't fuse, if you will, under normal circumstances. Even something as large as the Earth generates gravity, but does it generate enough gravity to cause fusion? Well, all you have to do is drop a golf ball. Watch. Well, no, it didn't fuse. It simply bounced off. Of course, that's some elastic energy. That's some gravitational energy being converted into elastic and sound energy. So there's lots of interesting things you can teach along those lines as a result of this, as a bit of a spin-off. But it doesn't fuse. It repels. In a star, they would come together like that, and they would fuse. And when I've got two protons together, this is now helium. Well, you can imagine that eventually the star, the sun, will run out of hydrogen. Now, it fuses a prolific amount of hydrogen, tons, thousands of tons per second. But how long will that last? It's like the gas in my car, or in my case, the charge in the batteries in my car. Eventually, it runs out. Will the sun eventually run out of hydrogen? And when it does, what will happen to the process of nuclear fusion? Well, here's what will happen. It will stop. Well, what happens when nuclear fusion stops? Because a star really is a perfect balance between fusion energy pushing out with gravity energy pulling in. And it forms an equilibrium in the shape of a ball. But if fusion stops, there's no more outward pressure. All there is gravity. And so it begins to collapse. And that collapse, at this point, the whole ball would be predominantly helium, forces the star into a new era of life called the era of helium fusion. Now the helium atoms begin to fuse with each other, and thus are born bigger and bigger atoms of the periodic table. So if I had two protons, helium, fusing with another two, that is now beryllium, the fourth element on the periodic table. And then perhaps all of the helium will be used up. Well, what happens then? Well, you move into another stage of fusion. And each stage of fusion results in bigger and bigger atoms of the periodic table. If a beryllium atom fused with a helium atom, I would have now 6 protons. Well, that would be carbon. If carbon, a 6-proton atom, fused with a helium, I now have 8 protons. Well, that's oxygen. And it turns out that our sun is large enough to fuse up to 8 protons. So oxygen can be formed ultimately in the core of our star. Not right now, because it's still in the process of fusing hydrogen, but in the future. And when that eventually happens, when the star runs out of elements that it can fuse, its life is basically over. So in the case of our sun, what's going to happen is, with each of these larger and larger elements being formed, there being a more and more energetic form of fusion, you get a bigger outward push. And the star does begin to grow in size. They say that by the time it gets to the ultimate end of its life, it grows from this size of 1.4 million kilometers in diameter to something large enough that will fill not only the orbit of Mercury, the orbit of Venus, but it will reach out to the orbit of Earth. At that point, of course, the solar wind will be so intense and the energy of heat will be so intense that there will be no atmosphere on Earth, there will be no water at the surface, life will not exist. Don't worry, this is 4 or 5 billion years from now, so we've got time to work things out. I wouldn't worry about it too much right now. Sometimes students do get concerned about this sort of thing. But at that stage, the stars become a red giant. And the star will eventually get so large that its center of gravity can't hang on to those outer reaches. And so as such, they just sort of go, whoosh, and off they go, away from the core. What's remaining is a white dwarf. That white dwarf with this large nebula of gases that's just sort of extending off. The star just got too large for its own good, and it lost itself, and off it went. And we watch this happening in other stars in the galaxy. We see white dwarfs with this ring nebula all the way around it. That's evidence of how our sun will eventually come to the end of its life.